and this is Will Lacoma. Together we have a number of curious and exciting topics to share with you.
As attendees of the Hand-Eye Supply Curiosity Club, you are all now members, provided you adhere to our philosophy. Ex Curiositas Scientia. We pledge to learn without prejudice in pursuit of our mutual goal, perpetual noviceship. We admit that it is impossible to know everything about anything, and thus we remain perpetually curious and perpetually novice.
This is our flag and our mascot, Franklin. The lightning bolt represents the receipt of knowledge, the enlightenment of illumination, the resonance of truths understood. It awakens and excites us and makes us hungry for more.
And now we are very happy to introduce Lyle Poland. He's of Hand Forged. He's a full-time metalsmith living in Portland, Oregon. Thank you.
Cool, excellent. Thanks, Tobias and Will, and all of the Core 77 and Hand-Eye Supply folks who helped make this happen. My name's Lyle. I live here in town, and I do metalwork, primarily jewelry work and blacksmithing work, as well as welding and fabrication too. How I got into metalwork initially is I grew up working with my dad, who was a welder and a blacksmith in Lake Tahoe area of California, and so pretty much grew up kind of by forced into the family business, learning how to weld and build railings and repair things and whatnot. And then when I got older, I started making stuff for myself for kind of enjoyment, and there came a point when I kind of decided to put all my energy into making things, and that's kind of what I'm in the middle of right now. What I want to talk about today is about blacksmithing primarily. It's kind of a trade that I think a lot of people have stories about, but maybe it's still kind of a mystery to some people. Like, what does it mean to be a blacksmith? What does it mean to forge metal? And I think that it's a pretty interesting craft, even especially because of the direction that it will be going in, and that some people are taking it in right now in contemporary blacksmithing. So what I want to do is kind of get everybody up to speed real quick about what it means to forge, what it means to be a blacksmith, kind of in a historical sense and sort of in a practical sense too. So we'll kind of all learn a little bit about blacksmithing, and then maybe look at some examples of work from some really talented blacksmiths from the past, and also some local blacksmiths, and then we can look at some of the work that I'm doing and talk about that a little bit. And if you guys have any questions, like while I'm talking, if I don't explain something very well, you could just ask me to go over it again. Okay, so that sounds good. Cool, so let's just jump right in, and we'll go back in time a little bit to like an old-fashioned blacksmith shop. And so everybody kind of has the idea in their head that like the blacksmith is this really big guy hammering metal, and it's really hot and dirty, and this picture kind of shows that. In the middle there's like three people, one person holding the piece, and that would probably be the head blacksmith, and then his helpers are swinging the hammers and working the hot metal on the anvil. Also in this you can see there's a person over here by the fire, and they're working what's called a bellows, and that essentially is shooting air into the fire to get it super hot, so you can like heat up metal to the point you can actually burn it. So this is an old wood cut. Here's an actual photo, and it's kind of the same idea. There's a guy, there's people on the anvil making a horseshoe or something, multiple people swinging the hammer, and this is typically what an old-fashioned blacksmith shop was like. The forge, there's a guy working the forge and the bellows, making sure the fire's hot and taking care of that, and and then it's all, the forge and the anvil are usually really close to each other, so you can just pull out a piece of metal, throw it on the anvil, start banging on it. So typically like things haven't changed that much in the layout of the blacksmith shop, but things did eventually change, as you'll see. So what are the people doing? Like, they're hammering metal. What is it that a blacksmith's actually doing? Are they just like smashing it and making it like smashing it and seeing what happens, or is there more control to it? And when you watch blacksmithing, it looks like really loud and dirty, and you might not see exactly what's happening, but it does take a lot of finesse and control. And so these are a few examples of the basic elements that pretty much the basic ways that a person can work metal, and when you put it all together, you can have like a finished product, like a fire screen or a railing or a tool. So in the top, in the top right corner, it's just a taper. So that's pretty much the simplest thing. Like, if you take a blacksmithing class, you'll learn how to just take a bar of metal and taper it to a point, and it is like the starting point to lots of different processes that, say if you're making a knife, you might start by making a point like that. If you're making a leaf, you might start by doing that. So it's a handy thing, and you use it, you can leave it as it is, like if you want to point anything to a fence, like a fence post, or if you want to turn it into a leaf later, you can flatten it down into a leaf. The next one in the middle is just an upset. It's called upsetting. It's when you actually widen the end of a bar by heating only the end of it and hammering it onto itself. So instead of elongating it, you're actually thickening it and smashing it back on itself. The next one that you see right here is a hot punch. And so blacksmith, typically a traditional blacksmith will try to do as much work on the anvil as possible. So you won't see like, say for example that's a part of a leaf that I was making. I don't get it to that step, then throw it in water so it's cold, go over to the drill press and drill a hole in it. I keep the steel, like, you put it in the forge, take it out, and do the next operation. So essentially, instead of drilling a hole, you can punch a hole using just a round punch. It essentially is something you'd hold in a hand, or hold in your hand, or with a tool that you would use to punch a hole through the metal. And this is something you can only do hot. If you have a hydraulic punch, you can punch holes cold, but you don't need to. So one advantage of punching a hole versus drilling it is you lose a lot less material, and sometimes that's important. And I'll point that out as we get around. On the bottom right, there's an example of a twist, and that's just a decorative element. That picture's of a railing that a local blacksmith named Arnon built, and he twisted the bar you might be able to see it, just to add a decorative element. And then in the middle bottom, there's a scroll, and that's probably the most classic decorative element found in ironwork, and you'll see that all over. And then this last picture, it kind of is a good example of how somebody might use all of those things to as little architectural elements in a finished product, and also as functional elements. So you can see right here, there's an upset end of a bar. Right here, it kind of tapers down, and all of these places where they connect were actually punched hot, and then the hole where they punched it, they spread out the hole. You can see it kind of bulge on the side, and then they did a technique of joining metal called riveting. So they to do a rivet, you essentially pass a bar between two pieces of steel. Like, this would be a piece of round stock that went from here to here, and then you upset both ends of it. So you essentially hammer it from both sides, and it expands and holds everything really tightly. So so these are essentially the basic there's other types of things that a blacksmith will do, but these are some of the basic ones. I guess the take-home message here is that if I was going to build something like a foot for a sculpture, for example, which this I think is a small part of a bigger project, you can just take a base plate, put a post on it, weld it around, and you have your foot for your sculpture, and it works fine. The fun thing about blacksmithing is that the functional elements of it are decorative elements at the same time. So all of these pieces are riveted together. So you kind of, when you construct something, you have all these opportunities of adding details that kind of don't necessarily take away from, they don't distract from your finished piece. Does that make sense? Yeah. Okay. Cool. So this is a nice example. I didn't make this, but I really liked the joinery on there. What else? Okay. So the tools that we use. Basically, there's the most basic tools is you have a forge, which gets hot. You have an anvil and a hammer, and these are what you need to get started. You don't need 100 hammers. You don't need fancy anvil or anything. You can use a railroad track and an old rusty hammer. It doesn't really matter. But anywho, I'm just going to go over these real quick. So there's two types of forges typically. The more old-fashioned way is a coal forge. It just shoots air into a fire of burning coal and gets very hot. And then the more common one now is using natural gas or propane, and that's what you see as the gas forge. So essentially, they do the same thing, just some people choose to do it one way or the other. So the anvil. The anvil has been around for a long time. That the picture in the top right is a piece of stone that was used as an anvil a long time ago. And then there's a few examples of, I just thought it's kind of fun to see the different manifestations of the anvil. It serves the same purpose in each of these ones, but they each come from a different time. One thing they all have in common is that they're big and heavy. They have a nice flat top, and most of them have a hole in the top, which is called a hardy hole. And you can see it right here. There's a little hole, and here, and right there. And so that is essentially like a little part of the anvil that can be really useful because you can stick other tools into it. And so here's an example of a little hardy tool that you would put in your anvil and use it as like a more specific for a specific use. So even what I was surprised to see is that even this like really old stone anvil that could be like 1,000 years old or so had a hole in it that they would use for however they could. So yeah, it's called the hardy hole. Next is some contemporary anvils. The upper one has a lot more functional spots on it than say the old stone anvil. And then the bottom one has sort of a different design, but a very very useful. It just does the same thing. It's just a new one. So this anvil is actually made in Port Townsend, Washington too, which is kind of cool. So you can buy them if you want.
Which one is that?
These ones, they're called Nimba is the brand, and they're made in Port Townsend, Washington. Yeah.
What is the purpose of the triangular sides of it?
That's a good question. So yeah, you have two sides, the round side and the more tapered flat side. And so the round side can be used for bending. Say if you stick a hot piece of metal over the end of it and you hammer it off center, it'll kind of follow the curve. And so you can use it for making a scroll or for other things too. And then this side, you might use this end of it if you have a part that that is a weird shape and you need it to like fit under the end of the anvil. Say if you're hammering a big a big U shape, and you can't get the you can't really rest it on the anvil flat, but if you kind of stick it over the end of it, you can still work it. So that's a good question. There's other more specialized anvils that are for particular uses like horseshoes or chain making and stuff too. So yeah. Okay, so the hammer, the other part of the equation. So I just wanted to illustrate here that hammers are pretty much, these are all examples of hammers found all over the world from different traditions and cultures, but they pretty much all do the same thing. Everybody kind of has a preference. Like if you meet a blacksmith, they might have a hammer that looks like one of these, and they would say, "Oh, don't bother with another hammer." And the thing that I kind of find fascinating is that some of these hammers were developed in different countries right next to each other, and became like the typical French hammer, the typical German hammer, or the Swedish hammer. And I don't really know why, but they're just known that way. So this hammer is a French hammer, and if you go to France, a blacksmith might use a hammer like that. Maybe they won't. But if you ever read, say, like a French cartoon like Tintin or something, the hammers in the cartoon will probably look like a French hammer, which is kind of funny. Then we have more of a German-style hammer, a Swedish-style hammer, and then this is kind of a more modern design. And then the most unique of them all is a Japanese hammer. And Japanese hammers this would probably be used for knife making or tool making. And it's kind of, when the first time I saw one, it looked awkward because it looks a little imbalanced and it doesn't look easy to swing or anything. But apparently like that style of hammer makes it really a useful hammer for drawing the taper of a knife blade or and other things. And so that's what they're used to using. And then this is an example of a hammer, a handmade hammer by a guy in California. It's just really pretty. So the Japanese, like an example of kind of like the cultural differences between blacksmithing. Like there's a lot of metalwork in Europe, there's a lot of metalwork in Japan, and they kind of developed on their own separately. So that's maybe one reason why the tools look so different from, say, like a German blacksmith shop to a Japanese one. So these are two pictures from a Japanese shop, and the thing that's kind of interesting is that the person forging here is actually standing in a hole so that they're below the floor level of the shop, and they're working on the anvil at really low to the ground with a hammer that has a different shape. And that's just the way that they developed forging, and it's how some people still do it today. So I was surprised to find that. All right, let's keep going.
I noticed all the hammers had like kind of a point on the back, or a flat point. What's that for?
It's a good question too. So that's true. They all have in common, they have a flat side and they have a more tapered side. And so the peen side, or the tapered side, is essentially used to control the direction the metal is moving. So if you want to move, say you take a strike at some metal and you want it to move equally in all directions, then you would use a ball peen hammer, because it's essentially a sphere on the end. So when the hammer strikes it, the metal spreads out away from that, kind of like it was a piece of clay. So these are, that's useful. You can forge with a ball peen hammer, but most of the time you want a little more control. So these hammers will kind of control where the metal moves kind of more directly. So you can stretch something out. If you hit it with the peen side, it'll stretch it, and if you turn it and hit it the other way, it'll widen it. So it's a useful Thanks for asking. Yeah. Yeah.
What is the reason that they want it to be lower than ground level?
See, I don't necessarily know unless it's maybe something carried over from a long time ago. Honestly, I'm not sure.
Well, one thing about that is that a great number of the traditional Japanese crafts are practiced while sitting on the floor,
Yeah.
and they tend to work that way. You see a lot in woodworking and other areas where they're actually sitting on the floor. And I'm actually involved in building cameras, and there's actually a camera maker in Japan where all the operations are happening while people are sitting on the floor.
Yeah.
It's just
It
something
is
about
really
Japanese
interesting. Yeah. Yeah. It's fun to see photos of carpenters in Japan hold like the way that you'll clamp a piece of wood. You might stand on it and saw it or you carve it. Same with the blacksmithing. They might be sitting cross-legged and having their helpers swing the sledgehammer while they forge a sword or something like that. So moving forward a little bit, this is essentially the same. Essentially, that's the same photo that we saw before, except for it's a lot quieter. There's only one guy in this picture, and it's kind of funny because they're showing like the blacksmith is in the center with his anvil, and then there's this other thing in the view, which is this tool right here, and that's what's called a power hammer. And when the power hammer came along, it could essentially replace all those people that were swinging the sledgehammers. So blacksmith wouldn't need to have 10 helpers swinging sledgehammers all day. You can use your power hammer, which essentially does the same thing and doesn't necessarily wear out or get tired. So right now I'm gonna show you a couple old, this is actually a picture of a modern blacksmith shop with a couple power hammers. The idea behind this tool is essentially you have a foot pedal that you step on, and then this ram kind of moves up and down, and you can forge really heavy stuff really quickly, and you can also do really delicate work too. So right now I just want to show a video real quick of one of the first power hammers, and this is it's called what is it called? It's called a Helve hammer. And it's one of the original power hammer designs, and they were originally powered by a water wheel. So, can you guys see that? Great. Okay. So let's see if we can. So the idea is that. Yeah. So there's the big Austrian blacksmith with his shirt off. And and this hammer is so unique. Anywho, it's essentially a trunk of a tree with a giant chunk of metal on one end and a wheel on the opposite end. And that wheel was typically driven by a water wheel that would kind of ratchet up the opposite end of the tree trunk and then let it fall. And so it would, once the water wheel was turning, it would just move up and down and up and down. So that's one of the earliest power hammers. And like as you can see, this video is filmed probably in the last few years. So there's some blacksmith shops that still have these types of hammers in them, and will occasionally fire them up, probably for demonstration. But I don't think that many people actually use these for production stuff. Because one of the more industrial hammers is a lot more powerful, but I thought that was kind of a cool thing. And so let's go back. So here's I don't have a video of like a regular power hammer working, but it's kind of fun to see. But that earlier hammer is a lot more interesting. So let's see. So here's another picture of the blacksmith shop as it kind of is evolved. There's lots of power hammers and other equipment, but the forge is still there. It's a gas forge, and it's a lot smaller. And it doesn't. You can just kind of turn it on, and it doesn't take an assistant pumping the bellows or anything, which is kind of nice. And then we're kind of moving into like super industrial And this is an example of a forge press, which is essentially a hydraulic press that you use to shape metal. Instead of using hammer blows to move it, it essentially just uses pressure and just pushes. So this could be a part for a boat or a power plant or who knows what. But in some super industrial places, they'll forge things that big. And I just want to I'll show one more video real quick. But the hydraulic press has become a useful tool for small blacksmith shops too, because a power hammer can be really loud tool to have, especially if you're not in an industrial area. And using a hydraulic press, I don't know, this isn't working. Anywho, that's okay. You can use a hydraulic press to move metal without the ringing of the hammer. And lots of knife makers will use hydraulic presses nowadays, and lots of contemporary blacksmiths will use it and get some interesting results from it.
Does it change the strength of the metal if you use the hot press compared to the?
That's a good question. So when you hammer metal, say like a power hammer does really powerful blows really quickly and actually affects the internal structure of the steel, and a hydraulic press might not do the same thing, metallurgically speaking. But I really honestly don't know. It doesn't. Forging, say traditional forging, might be better, but it's more for the end result that they would choose. So if you're making a tool, you probably wouldn't use a hydraulic press to make like a knife. You'd probably use a hand hammer or a power hammer. Anyway, so this is an example of some work that's using some more modern technology. This is a fire screen that a shop in the Midwest called Red Star Forge. They built this. So what's different about this is like it's a kind of a cool design. And instead of forging each of these like modular elements, what they did is they had their design cut out with with either a laser or a water jet cutter, and then they did a couple operations on it to like give it some more 3D, to twist some parts and then put them all together. So this is something that you could forge to shape, meaning heat up a bar, hammer it to shape, and get them all exactly alike. But they kind of chose to use a more modern tool where you can essentially design a part on a computer, send it to a shop, and they'll cut it out precisely as you like. And then they did some more operations on it to turn it into this fire screen. Not that many blacksmiths will do things like this, but I thought that it was a good, successful use of something like a laser cutter or a water jet cutter in a forged fire screen. See, this is a couple examples of using non-traditional tools. The candle holders were used using a hydraulic press. So you would essentially take maybe a piece of round material, like a small couple inch long piece, and if you just squish it in the middle and put an indentation in it, the outsides of the steel kind of start to collapse, and you get some really interesting results. And that form of the candle holder isn't something that you would get by hammering. You couldn't really get the same sort of result. So that's a nice. So you can, if you're say using a hydraulic press in your shop, you can incorporate like design elements like that into your work pretty easily. This is another example. This is actually a face. Like somebody, if you were really talented, you could forge features like that with somebody's help. But what's unique about this piece is that it was forged using pneumatic hand tools, which would essentially be like a small jackhammer with a hammer instead of a pointed bit or a chisel in it, use like a rounded hammer bit, and you actually shape the hot metal with essentially a jackhammer. And that I just learned of yesterday, so I didn't know anybody was doing that. So what's kind of cool and about these last few projects is that they aren't traditional, and I think that it's exciting to see people kind of inventing new ways of using tools to work metal, especially in a trade like blacksmithing, where it's kind of has typically been such a traditional type of thing where one person passes the knowledge along to the next and so on. So these are some fun examples of techniques that you probably wouldn't learn in an old fashioned blacksmith shop. Okay, keep going. This is an example of some modern knives. These are made using a hydraulic press to essentially weld together lots of layers of steel. And you can actually get this really decorative pattern into the steel. The one on the top actually has little dinosaurs in it and mammoths. And then this one, it looks like it has some sort of like horse figures in it. And these materials are called mosaic Damascus, and it's essentially just you kind of weld different types of steel all together. And the thing with tool steels, like the steels that you would use to make a chisel or a knife or a drill bit, there's lots of different kinds of them. So you can weld together all these different tool steels, and when you're done, it might be one solid piece, but it actually still retains the different properties of each layer of steel in it. So it can be revealed once you grind and polish the blade.
So is it like welded together in a larger format and kind of stretched out?
Yeah.
Like you would do glass or?
Yeah, if you're familiar with like making a cane of glass, which would be like, if you looked at it on the end, you could have like a flower pattern or something. People would be doing that with different types of steel, and you'd make a big chunk of it. Then, like in this example, they might slice it up and stack it next to each other and weld it again. Or you can, you don't have to cut it apart to reveal the pattern. You can kind of carve into it and unfold it too. So this is kind of like the edge of. So some knife makers are doing stuff like this right now, and it's kind of new and really fun to see. Okay. Now here's some examples of some contemporary blacksmiths' work. This is an Italian blacksmith. So this is a gate. It's pretty incredible. These are two other pieces of his. So the way that this guy works is he'll usually work with lots of helpers, and he'll shape each like element for, say, this railing or for this figure. He'll be kind of he'll be holding the hot piece of steel, and in one hand or with some tongs, and in the other hand have essentially a tool, which would just be a special type of hammer. And then have his helpers strike the hammer exactly. He'll put his tool down, and then the people will strike it. And so he has really a lot of control over how the metal is shaped. So there, like in examples like this, there isn't like there's no like torch cutting. There's no grinding. There's things like that. All of the metal is entirely shaped kind of by sculpting it hot and like it was clay. And to do this, it takes a tremendous amount of control, and even if you blacksmith your whole life, you'll probably never do this. Yeah. I don't think. I wanted to show Arnon's work. He's a local blacksmith and a nice guy. He actually teaches forging classes at his shop, so you could look him up and give him a call and see if he's doing that. He works with stainless steel a lot, which is not so traditional to forge, and is a really difficult metal to work with. And so his work is really stunning, I think. And these are some tools and knives that he's made. And there's a handful of blacksmiths in Portland too. So it's good to know that they're out there. And there's some incredible ones in the Northwest in particular. And then this is an example of an old-fashioned blacksmith. This guy, let's see, he's an Austrian who moved to Milwaukee, and he lived there in the late 1800s to like the middle of the 20th century. And this is a piece of his. It's like essentially like a window grill, and it's all forged to shape. And I think it took like years and years to make. But this is an example of this is something that lots of blacksmiths will look back on and like have no idea how it was made. So in some ways, the masterpieces of metalwork that you might see if you go to Europe, and you'll wonder like how was it ever possible to do this, and why? And it's true, like maybe we won't be able to do it today because those types of skills haven't been passed on, which is, you know, maybe it's okay, but but at least some people, you know. What's encouraging though is that there are some working blacksmiths today that are doing incredible work and kind of pushing the boundary, but you know, some people are just incredible artists. So this is a good example of one of them. Yeah. Cool. All right, here we go. Now this is some of my work. This is a mirror frame that I built a few years ago. Essentially, this is a fun project. It was not a commission, so I kind of had freedom in what it was going to be. It was for a gift. Essentially, what I wanted to do at first was to make like a realistic branch, sort of like an aspen leaf, like a tree trunk with a branch and some leaves on it, and do kind of like a natural history type forged piece. And when I was working and starting it and drawing it on the table, which is a nice way to start, where you can draw directly on a steel table and then build your pieces to your drawing. I started just drawing with lines and came up with this design somehow, and it was really a pleasure to build it because it kind of happened really naturally. And so I kind of kept the form of the tree, but really stylized it and broke it down into lines and just different elements that I joined with rivets. So yeah. And this is there's no like side to the mirror, or the mirror frame has one side open, and I liked that too because I didn't want to make just a square or rectangular mirror frame, honestly. So.
Are the rivets a different metal? Are they steel?
In this one, they're copper. You could make them out of steel too. Copper rivets are kind of nice to use because you don't necessarily have to heat the rivet to set it. Whereas if it's steel, you would have to have your two pieces with your hole, put a hot rivet through it, and then put it on the anvil and hammer it. But with a copper rivet, you can actually do it cold, which is convenient. And if you need to hammer it more, then you can heat it up with a torch and continue on. Rivets are great. Like, I use rivets in almost all of my work, and it really kind of encourages you to think out the whole fabrication process before you even join a rivet. For example, like if I was to, in some cases, like if you set one rivet, it'll prevent you from setting another one. So on this one, I'd have to look at it for a minute to find out which ones which order I did it in. But it's something that you do have to figure out before you start setting your rivets. You can have all your holes drilled and ready to go, but I'll show you an example. This is another design I did. This one, it kind of I actually have more process photos of this. So this is for a client who wanted a decorative grill for his bread oven, and it was a good opportunity. He is a baker and built this really nice brick oven, and then wanted some ironwork for it. So he said to just do whatever I wanted, and which is kind of I don't really like that. It sounded really nice when I heard it, but it kind of I'd rather have some direction when working with making something for somebody's home. But this is what I came up with. He had no idea what I was doing, so I had a fun time building it. It was a challenge. And so it's all connected with rivets too, and we have kind of like the starting point here. So I like the idea of using a modular elements, essentially like making a lot of these little offset pieces where I would taper a piece of steel on both ends, put a little offset in it, and then start assembling them in to build kind of like a picture. So you can see at first I just offset them. There's no curves to it, and then I adjusted the ends of them and bent them and kind of gave it a little more character. And then in this bottom picture, I start actually marking them out, so I know where to drill a hole to do a rivet, and say it gets kind of tricky because as you take a part away, or you might forget where it goes, and so I had to keep everything kind of organized, so I knew exactly where each part went back together. And this is a good example of like some rivets like were really hard to do, but it came out in the end. Yeah, so that was fun. There's the only welding on this I did with a MIG welder is these guys here. They're essentially one piece that's folded back on itself, and then you weld the fold, and then you can taper it out like it was a solid piece. And so it's kind of fun to build something piece by piece, just forging the shapes you need as it is built. Okay. So this is actually something I made recently. This is a really simple coat rack design, and it's fun to make. It's all done on the anvil as well. And the unique, at least in my mind, the unique part about this is that these hooks kind of dangle, and they're not mounted hard to the board, except for on the two ends where this main bar attaches. And so you just use a piece of 3/8 by 1.5 inch steel, punch the holes in it, enlarge them, and kind of flare them out. And then when I make each hook, I make sure that they are, you essentially make them and then fit them around the hook and hammer them so that they won't come off unless you heated it up and bent it again. And this is kind of fun. It reminds me of really kind of old-fashioned mining town type of blacksmithing in some ways. And that piece of wood is kind of cool too. It's from the Rebuilding Center, and it's I just planed it and oiled it, and so the wood kind of adds a different element to the finished piece. Yeah. Okay. So now I'll just show you like step by step how I make this bottle opener. This is like a leaf, and the reason why I want to show you this is because it's made entirely on the anvil. In about a half an hour, you can start with just a piece of 3/4 inch round stock, like a solid piece of steel, and you can actually go through step by step and make a bottle opener. And it's fun because essentially every heat, like when you put it in the forge, bring it out, hammer it, it gets cold, put it back in. About every heat, you take it another step of the way. Sometimes you can do 2 steps in one heat, but sometimes you can't. Anyway, so you can just see how it goes. Start with the bar, taper it, then start making a stem right here, and then you essentially start to flatten this end out into the what will become the leaf. And so if I was just going to make this leaf for a railing, I would get it here. Then I would use a ball peen hammer and probably just widen that leaf out and spread it out until it had a really nice shape. And you can kind of, you can correct it a little bit, but it's nice if you just hammer the steel, let it spread out, and it usually gets a nice form that way. But in this case, I punch it because it's going to make for the, where it fits for the bottle opener. And instead of thinning out the steel and expanding it, I instead of, hammering the steel to get the leaf shape, I kind of stretch it out into this, and then it gets the form that I want. So you can see it each, you take it a little ways, heat it back up, and drift it a little bigger each time. Then once it gets here, it's pretty much almost done. Then I'll stamp it with a little tool I made to stamp the little pry bar part, which you can see right here. Then after that, I just do the little finishing touches on it and clean it up, and then cut it off the bar. And you can actually cut it off the bar using this. If you don't want to saw cut it or use a grinder, you can you set that in the hardy hole and use it as a cutoff tool. And then you have your bottle opener. What I do, I have a few bottle openers up here, and then what I do by hand is I file and fit this little pry bar part so that it fits really good. And that's the one thing I do that isn't on the anvil. So I have a few designs, like this is one of my earlier bottle openers, and it's forged. Then this one's a mix, this one's cut and then forged and riveted. And then this one I like because it's easy to make it. You can make this anywhere.
You mentioned you have a shape that you use to finish out the initial shape of the bottle opener. What is that part made out of?
You mean like what I use to widen the hole?
Yeah, I think so.
Yeah. So the bottle or the leaf shape just develops as you stretch that hole. So I use like essentially a long tapered punch so in the beginning it's just widening the hole a little bit, but as I get down here, it's maybe almost an inch wide. Then I have an oval shaped punch that when I pass that through, it actually gives it more of an oval shaped. So I don't do any hammering around like the edge of here or here, and I try not to hammer this because I like to leave it kind of like as a square taper. So like say right here, I might clean that up because it's a little square right there, so maybe I would hammer that, but does that answer your question?
I think so.
Okay. There's not like a template for this type of thing. So there's the bottle opener. Then this is a railing I built recently. This has, you can see the leaves. The pictures aren't that great, but this is essentially I make the leaf in a similar way. I don't punch a hole in it, I just spread it out, kind of like this. So you just dish out the inside of the leaf to get it to shape, which is kind of fun. And then this one has rivets connecting it. So all these pickets are all connected like in a couple places. And so I essentially build like the skeleton, which is the top cap right here, the post, and this bottom piece. And then I built all of the pickets as one, and they're riveted together. So then I kind of just set the pickets in there, which takes a lot of time to fit and rivet all the pickets together. It does take a long time. Then you just weld it in place, and it's good to go.
With the modular pieces, are you creating a template on a drawing on a handle or something that you're shaping it to?
Yeah, that's a good question. So I'll usually do a scale drawing on like the ground or on the table of the scroll that I want, and then I'll try to make one, and then I'll usually make the next ones to that. But typically, say if there was 50 of them to make, you can make a jig, which is essentially a tool that when you put your bar into and bend it around, you can make the same bend 50 times and they'll all be pretty much identical. And in some ways, like, that might be easier than me. Like, even just doing these 4, sometimes they can give you trouble getting them all alike. But
Do you use jigs much in your work, or do you have a small number of repeating pieces that you don't need?
Jigs are really useful, especially, say, with if I'm going to make something to sell, then I'll make a lot of them. But say for this is a railing, and I didn't make any jigs for this one. But if you go to a blacksmith shop that does big projects, they'll have tons of things and piles that are for bending and stuff like that. So, but it does make your life easier, and that's one of the kind of cool things about the blacksmith shop is that it's constantly like reinventing the tools that have been used for hundreds of years. So, like, say each person will maybe have a different way of making their bending jig, or they might invent a whole new tool. And in the blacksmith shop, you can make a new tool right there on the anvil while you're making a railing or something, or a bottle opener. So that's kind of cool. Right. Then this is an example of some belt buckle I made. This is kind of comparable to that oven grill in the sense that it's all riveted together, but it's using really small rivets. And I did some soldering on this too, but it's kind of it was a fun project too for a tennis tournament in San Francisco. And then this is a knife. These are some process pictures of a knife I made. The top one shows my drawing and the original piece of Damascus that I was using. And this is kind of interesting. What Damascus is a laminated material. I don't make Damascus like those other pictures I showed you with the dinosaurs in them. What I do is I just take sheets of one type of steel, alternate them with another type of tool steel, and you weld them together so you get kind of like a lasagna of steel that's all one piece. Then you can start manipulating it to bring out the pattern. So what I did here is you just do little divots with I used a cutting tool, like a drill, to kind of drill little half holes into it. And then I heat it up again and hammer it flat. And what was in the bottom of that divot now is on the surface. And I have this knife here actually, and you guys can look at it later. You actually get concentric circles from cutting into the layers of the steel. So same thing with this is a material I make called moku megane, and it's laminated copper and brass, but it's only used decoratively. It's not used for tools because it's too soft.
How thick are the layers?
In the beginning, they might be like a 1/16 of an inch thick or so, and then I might have a chunk of steel with 20 alternating layers. Then I'll hammer it thin, chop it up, and stack it on itself. So I might go from 20 layers and I weld it again to 100 layers, like do 5 welds again, and then I might hammer it to this dimension and grind a groove into it or cut some divots into it, and go from there. So in the end, though, it might be over 100 layers in one knife. So the actual layers of steel are really thin.
When you say you weld them together, are you just laying the steel on top of one another and putting it in a forge and letting it get hot?
Yeah, what you do is you take your steel, put it in the forge, and get it up to a super hotter than you would normally want to get it, above 2,000 degrees, and then you pull it out and you gently hammer it, and the layers can bond together.
You're welding it by hand to get it hot.
Yeah.
Are you adding it layer by layer?
No, you can do multiple layers at once. Yeah, you can do say like some people will you can just weld two things together, or fold something over on itself and weld it to itself. With the Damascus, it would take really too long to do it layer by layer, which is kind of more what a Japanese metalworking doesn't involve, like making a lasagna like this. It involves making one type of steel and refining it by folding it, again and again to get the pattern and to the steel. Whereas this, I start with different types of steel, and in the end, you can still see the layers.
What was the name of the brass and copper?
It's called Mokume Gane, and it's a Japanese metal smithing technique that was developed on it, like kind of separate from this decorative knife making technique. And so somehow in Japan they learned how to do this with things like silver and copper and gold, and it's really pretty. You can see some examples of it up here too if you want. And then this knife has abalone spacers, so the abalone it was incorporated into the knife, and then the wood is manzanita from Santa Cruz. So that knife is made entirely from scratch, which was a fun project. Cool, that's it. Hey. So yeah, if you guys have any questions or want to come check stuff out up here, feel free.
What's the mix of metals in your hammer and anvil relative to what you're actually working with?
You saying like the alloy of the hammer
Right.
steel and the anvil steel versus the steel you're forging?
working
Yeah, so typically a hammer is made of a tool steel, not the same type of steel that you would make a knife out of, but a really tough steel that's probably more shock resistant. And so when you buy a hammer, maybe the manufacturer will tell you what the actual alloy is. And people who make hammers, like blacksmiths who actually make tools, they'll use a few different types of steel. And then typically the steel that I use the most is just mild steel, which you would make a bottle opener out of, or a railing, or a leaf or a hook. And then when I make a knife, I'll use an actual tool steel, which you can buy or you can find you can recycle it too.
I've heard that the iron that they used to work with isn't really made anymore. Is that true, or is there a source for it nowadays? Or
Wrought iron is a material that a lot of blacksmiths used a long time ago because it's the material that was it was common. There wasn't so much steel, and so if you want to use wrought iron nowadays, you have to like get it from an old fence or something.
Yeah.
And some blacksmiths will collect that. And the cool thing about wrought iron is that it's coarser and more fibrous than steel, like typical steel that we know. And so it's if you have to kind of hammer it gently because you can have all the fibers kind of come apart on you. But some blacksmiths will use it because in the end the result can be really beautiful.
yeah.
I don't forge much wrought iron though, except for I'll occasionally find it in like. If I use some reclaimed steel, sometimes it'll be wrought iron, and you might not know until you work it. At least I don't know.
Are there any lasting differences between wrought iron and steel?
Say that again.
As far as like outdoor work, I know a lot of wrought iron started out being expensive on outdoor applications. Is there any difference between steel and wrought iron work?
Well, besides like the wrought iron, kind of you have to be more delicate when you hammer it to avoid it coming apart. And in the end, like steel and wrought iron will both, if you don't paint it or seal it, it'll probably rust like outdoors. But wrought iron if it corrodes a lot, you'll actually see like the fibers in the steel. So maybe like if you saw, where would you see it? Maybe like a chain, like a really old chain link, like at a shipyard or something, might be wrought iron. And if it's all corroded from the ocean, you might see the actual grain of the steel. Yeah.
When did wrought iron really fall out of favor? Like that?
I don't know, honestly. Yeah, good question though. Cool. Well, I have some examples of things I've made up here. My work nowadays is a mix of blacksmithing and jewelry making, and you can see the intersection in some of my pieces. And so come and have a look if you want.
All right.
Yeah.
Let's have another hand. our next Curiosity Club will be on April 17th with Joe Deemer. He makes handmade bird cages, and it's called The Painless Appeal of Stainless Steel. He has a metalworking shop in the Southeast Industrial District of Portland where he makes fantasy bird cages and other wire goods for home and battle. His aesthetic is elaborate and curvilinear, referencing bygone eras and cultures. So, should be great. And yeah, thanks a lot. Man.
Yeah.
And everybody come up and check out this amazing work.
Yeah.
What kind of metal do you have on your money band? What kind of metal?
This is Damascus steel.
You made that yourself?
Yeah.
The color of the steel, it's really cool.
Yeah. Thanks. Yeah. It's
Did
different.
you kind of rough it up to get that? Or
No, you etch an acid, and the acid attacks to different types of steel differently, so you get that topography.
Cool, much like with a wrought iron, but on a smaller scale. It's etching
Yeah.
out the individual
Exactly, yeah.
steel.
In that blade, you can actually see a good example of the Damascus wood grain pattern. Yeah.
Do you do a lot of rings?
Lately, I do. Yeah. Some of these are for a show I'm doing, and some are for a client. So these are just some of my most recent things.
Holy shit. So how long does the process for making the farm?
Well, to make Damascus, it could take, you make a big chunk of it, and it could take a day or two to make the material. Then you have to work it like it was a raw chunk of material. So that takes a lot of hours.
So I was thinking more just to make the raw, because I've seen people work at Damascus once they had it, but you're talking about actually making it. I've never been there where you actually made it.
Yeah, it's fun. It's worth making. Same with the mokume.
I've only seen that with fine like gold and silver before, and it's so gorgeous.
Yeah, here's a
It's
nice
some
example of it. Yeah.
It's so cool. Is that a similar time frame, or is it a little bit shorter? Is it softer?